error control, flow control, access control, all these. So we have seen one by one. So for error control, we have studied different error detection and correction algorithms. For flow control, we have studied different algorithms. For finally access control, we have seen so many protocols or so many algorithms are implemented. So however, the data link layer function is it is used for the transmitting of the data link layer, in a sense the original data that is going to be available in the form of a frame. So that particular frame should be accessed or should be transmitted reliably, safely and securely from one station to another station. And we have considered different type of networking environment, that is switched networking environment. Only we are having two stations which are communicating. Another one is broadcasting networking category. In that, multiple stations are going to be communicated. So in all the scenarios, we have implemented different algorithms one by one for the proper data transfer in terms of frame from one station to the multiple number of stations, or multiple number of stations to the single or multi stations. Okay, this is about the data link layer. Okay, here only the data in the form of the frame is going to be sent over between the stations. If any error or if any collision is there, or if any losing or if any damaging is there, that particular frame is going to be recovered with the help of flow, error, and access control techniques. What we have studied is, if that frame is lost, we are going to recover that. If that frame is damaged, we are going to recover that. If that frame is not transmitting at the predefined rate, we are going to provide the flow control. Okay, and if that frame has to be sent over to the multiple stations, how we are going to send one by one. At the same time, if while frame is transmitting in another direction, if another frame is coming, then what we are going to do is, if collision is going to be happen there, that collision is also going to be recovered in the data link layer. So this is about the data link layer. So in continuation, the next layer above the data link layer in the OSI layered architecture is network layer. That we are going to study about the network layer in the fourth chapter. That is about network layer. And as we discussed the some of the primary functions in the OSI layered architecture, the main primary functions of the network layer is the okay, these are the primary functions of network layer, that is logical addressing, and second one is routing. Okay, for the implementation of this logical addressing and routing in this chapter, we are going to see different mechanisms or the techniques, how we are going to address logically the devices or the stations, that is computers, and then how we are going to provide the routing path in order to transfer the data. That is a function of a network layer. Okay, here this particular network layer is going to be focused on, suppose let us consider that the two stations, the source and the receiver. Okay, here the physical representation of these devices and the data available in the source and the receiver stations is going to be taken over by the physical layer. That is the first layer what we are having in the OSA model. And then when the two stations are going to be communicating, what is the data we are going to transfer from this station to this station, that particular frame, the desired data in the form of the frame. So for that particular frame, how this particular frame is to be transferred, and how that particular frame is going to be recovered if it is lost, or if it is damaged, or if there is a collision is there, that we are going to study it in a data link layer. That is the second layer in the OSI layer architecture. So these are over, and next we are moving on to the next top layer in the OSI model, that is the network layer. Okay, here the network layer in the sense it is also some sort having the relation with your networking path in between a source and the receiver station. But networking in the sense the devices, how the two devices are going to be making a networking. That is, this is going to be concentrated on a networking path in between the two devices. Okay, and here this particular network layer ensures that the information transfer, that is the packet or the frame transfer from the two stations, that is whether it is from this particular station and the destination is this particular station, that is going to be taken over by the network layer. Through this particular network, the network layer is going to be checking that whether is it in a proper origin from where we are going to transfer the data, or is it the desired destination device to where you are going to transfer the data. అంటే అసలు ఎక్కడ నుంచి ఇన్ఫర్మేషన్ తీసుకోవాలి, అంటే యాక్యురేట్గా ఇదే డివైస్ నుంచి డేటాను తీసుకోవాలా, ఏ డివైస్కి పంపించాలి అంటే the network layer, for the purpose of networking two devices, it is going to be concentrating on the device uh, characteristics. Means that the device identification, whether it is an origin and the desired destination or not. That means this network layer is going to be responsible for the packet delivery from the original origin device and original destination device. Whether as these two are the trusted devices for communicating the information, are these trusted devices or not. So these two devices are going to be identified by this network layer for the purpose of networking those two stations. That is the purpose of the network layer. So to identify that particular devices to provide the networking, one should know is the addressing. That means these particular devices are going to provided some address that is called as the logical addressing. Okay, already in the physical layer also we are having the physical addressing. Okay, what is meant by the physical addressing in the data link layer is the device identification. Means that why, because if you are having let us consider two computers, and the device availability and the device structure both are same, both are the computers and both are having the same characteristics. Suppose if it is built with some internal memory, let us take that 1 gigabyte, and if this system is also made with your 1 gigabyte, so that is the structural or the appearance of your device or the existence of the device we are giving. That is the physical addressing. Okay, the device identification, whether the devices are available or not, that is the physical addressing we are giving. But the logical addressing in the sense, even though the devices are having the same characteristics, ఇప్పుడు డేటా లింక్ లేయర్లో రెండు డివైసెస్ ఎలా ఉండాలి, ఈ రెండు డివైసెస్ ఒకే రేట్లో డేటా ట్రాన్స్ఫర్ చేయాలి, ఒకే స్పీడ్ మెయింటైన్ చేయాలి. ఒక ఆల్రెడీ వీ హ్యావ్ సీన్ దట్ ఇన్ ద ఫ్లో కంట్రోల్. That is, both are should be maintain the same speed and both are should maintain the same capacity. That means the characteristics of the devices are same. So we are having how we are going to discriminate these two devices, even though they are maintaining the same or the similar characteristics, is with the help of another identification we are going to differ those two devices. That is called as a logical addressing. Okay, here we will see very clearly and in depth what is meant by logical addressing, what is the different ways we are having to represent the address for a particular device. With that particular address identification, how we are going to do the data transfer, that we are going to see very clearly in this chapter. And second one is coming to the routing. Suppose if the number of devices in the real world, if the more number of devices are going to be communicated over the network, and as we are saying that the number of devices existed or having the multiple or having the, even though they are having the similar characteristics, all these multiple devices are going to be in communicating mode. Suppose let us assume that if they are in communicating mode, so for which devices now we have to implement the communication. Means that at the same time at the same time we are not going to deliver the data. If you are having the number of devices there, for all those devices how we are going to communicating the data. Means that we are going to provide a network path or we are going to create a network path from one specified device to another specified device. That is called as a routing mechanism. Okay, we are going to see very clearly about all these primary functions of this particular network layer. So as I told that this particular network layer, it's ensure that it's a proper packet delivery from the specified source device and a final or the desired destination device. That is the function of a network layer. Ante it will provide a networking link only for the identified devices only. Okay, even though the devices are available physically in the even though those devices are having the data, but this particular network layer will provide only this particular network link to transfer this particular data only when these are identified with the specified addresses. Suppose if this address identification is wrong, then the network link is not maintained between these two devices. Only the network link is maintained between these two devices. Only these two devices are found that they are having some error-free addresses or some valid addresses. అంటే ఇప్పుడు suppose if you are not having the valid address, well, suppose let us consider a simple example. When you are posting a letter, without having any address, we can't transfer that. But the information is there in that letter, and the letter is available here. That means the source device is there, and the information is also there in that particular source device. But this particular frame will be transferred, error or error free will be taken by the data link layer. But this network layer will provide only this particular networking link, this particular network path. Only these two devices are identified as ఒరిజినల్ అడ్రసెస్. అంటే ఈ రెండు డివైసెస్ ఒరిజినల్ అడ్రసెస్ అవైలబుల్ అయి ఉన్నాయి కాబట్టి, అంటే ప్రాపర్ అడ్రసెస్ కలిగి ఉన్నాయి కాబట్టి, అట్ ద సేమ్ టైం ఆ అడ్రసెస్ మధ్యలో ఇన్ఫర్మేషన్ ట్రాన్స్ఫర్ జరగాలి కాబట్టి, దెన్ this particular network layer is going to providing a networking link between those two devices. That is the purpose of a network layer. Means that a logical addressing in a sense, this network layer is going to be check over the address, the logical address of the devices, whether this particular address is a valid address or not. And if it is found as valid address, then these devices are going to be form a network path. Then only a network is going to be established between those two devices. So the packet delivery reliably can be done or not is depending upon the identification of the ఒరిజినల్ డివైసెస్. అంటే ప్యాకెట్ డెలివరీ రిలయబుల్గా జరగాలి అంటే అసలు సో ఇప్పుడు ఈ డివైసెస్ అనేవి అసలు ఒరిజినల్ డివైసెస్ కాదా అనేది చెక్ చేయాలి అంటే వీఆర్ హ్యావింగ్ సమ్ వ్యాలిడ్ అడ్రసెస్. సో వీఆర్ గోయింగ్ టు చెక్ దట్ పర్టికులర్ అడ్రస్ వెదర్ దట్ పర్టికులర్ అడ్రస్ ఇస్ ఎ వ్యాలిడ్ ఆర్ నాట్. So like that, the address identification of the devices, the original devices, is going to be taken over by the network layer. This is about the definition and the primary function of a network layer. And now, as we are living in the internet world or the internet working environment, now we are also going to focus this particular networking path in our internet networking world. That is, suppose if the two computers are going to be communicating, okay, two computers in the sense through internet. Okay, it is from one side, and at somewhere which is very far away, it's a computer one, and it is another computer. Let us say it is two. So when these two computers are going to be connected through internet, okay, so how they are going to be communicating? Already I told that the devices are having the similar characteristics. That is only the physical appearance and the physical identification is done by this physical and the data link layer. But the communication between these two devices are to be provided only when these are having the valid addresses. If they are not having the valid addresses, this particular networking path will not be provided, and we can't providing any communicating link there over those two devices. So in the internet networking environment, what we are doing is here, if you are going to communicating with one device, or if you are going to communicating with multiple number of devices, okay, yes, there is a possibility is there. There is a need to communicate with multiple number of computer systems. which are going to be connected through LAN or which are going to be connected through WAN. Okay, we are having different types of networking environments. So in this internet world, we are going to use either LAN or the WAN. That means all these systems are going to be interconnected. But here, the data transfer to these particular all these devices is going to be defined with some address. So usually we know that the term which is going to be used is the IP address. Okay, you already we know that what is the address we are going to represent to identify a particular system is the an IP address. Okay, here what is the importance of the IP address and what is the format of an IP address, and how this particular IP address is going to be identify the originality of the device existence. That is it an exact source station or is it as an exact destination station or not? So that is going to be decided by this particular IP address, where IP is nothing but internet protocol. Okay, here in the internet working environment, what is the address we are going to use is the an IP address. Okay, here, according to the history, this particular address is going to be available in different versions. But nowadays, what is the version we are going to use is version 4. That is an IP Internet Protocol address. That is an IP V4, means that it is a fourth version of the IP address. And the address representation, how many number of bits we are going to use for the representation of this particular IP address is we are going to use is the 32-bit address, 32-bit length for the representation of IP address. Means that as we are using the 32-bit length for one IP address, how many number of address spaces are possible is 2 power 32 number of address spaces are possible. As we are having 32-bit representation for one address, how many number of IP addresses we can represent is maximum we can represent it as a 2 power 32. That means almost the 2 power 32 in the sense how many number of computer systems may be communicated అంటే ఇప్పుడు ఇలానే కంప్యూటర్ సిస్టమ్స్ మనకు కమ్యూనికేట్ అవుతున్నాయి అంటే మీనింగ్ దట్ in this particular 2 power 32 it is having one IP address and it is having another and it is having one more address and it is having another IP address like that. So with that, how many number of devices we can connect is almost we can connect the 4 billion number of devices, 4 billion number of computer systems we can connect. We can connect. Okay, now as everything is the digital system, now what they done is another version is implemented in order to represent the IP address. That means now whatever the version they are using is okay. Now practically it is not implemented, but the version is ready in order to represent the IP address. That is an the next version is the 6. That is Internet Protocol version 6, where we are having 128-bit representation for IP address. Okay, with 128, we can say that it is 2 power 128, means it's an almost unlimited number of address spaces are there. So we can connect the unlimited number of the computer system to for the purpose of communicating any data. Okay, here, what is the importance of this particular IP address is with IP addresses, we are going to communicate with different devices. See, in making the computer networking environment with the help of this IP address, no two devices are maintaining the same IP address. That's the one thing. Okay, again I repeat, no two devices are having the same IP address. That's one thing. And second thing is, suppose if any address is used by one computer system, that can also be used by another system when this particular system is in inactive mode. Like that also, we can use this particular IP address. Okay, basically, while maintaining the networking environment, every device are going to be identified with some specific address. That is an IP address, and that is an unique. Okay, that particular IP address is an unique first thing, and unique in the sense we can say that it is an universal. Universal means everyone can identify. Why? Because that particular IP address is having a specified format is there. So as it is an unique, it cannot be used by any other device. Suppose if you are going to increase your networking environment, we can also reuse the one IP address when that particular IP address is inactive by one device. That is also one flexibility is there. Okay, now as you are connecting the unlimited number of computer systems over here in your internet networking environment, how these particular devices are going to be communicated. Now, how we are going to identify this with the help of an IP address? We are deferred all these particular devices, and now we have to provide the communication. That is a data transfer from this device to a specific computer system. So how we are going to provide this particular data system is, what is the next functionality we are having? That is the routing. Okay, here now we are going to see that different routing algorithms which is going to be used to helpful for the identification of the uh, defined logical addresses at the same time which are not repeated, which are not used by any other device, or which is that particular address which is not in use. Okay, which is not in use in the sense no other device is using that particular IP address. So IP address is an unique in the sense for every network, for every node what we are connected in a networking environment, we have to provide in such a way that that is an unique. So no other device should not maintain the same particular IP address. Suppose if you want to use that particular IP address, whatever the device utilized that particular IP address earlier, that should be inactive, means that we can transfer that particular IP address from that particular system to the another system. Like that, we can use that. But here, how we are going to transferring that particular IP address and how we are going to transferring that particular data over among all the different devices which are identified with a specified IP addresses is can be handled by the routing mechanism. Okay, that we will see clearly in depth. And along with that, what we have to know is this particular internet environment, that is whatever the computer systems or whatever the nodes are communicating, with the help of network layer, we are finding the specified address. At the same time, with the help of the routing, we are providing that. So maximum the problem is solved. That is communicating the specified devices only and routing the or providing the network path between the specified devices with the help of the network layer. But here, for the completion, for the successful completion of this type of networking environment, what we are going to provide is, here usually this particular networking is also going to be completed with the in the some sort of hardware and software. Okay, hardware in the sense whatever the physical layer and the data link layer and this particular network layer, the representation of the physical device and the characteristics of the data by the data link layer, and the representation of the address, the IP address by the network layer. And along with that, what we need is some sort of software is also needed. That is, a software means the tool is to be needed, which is going to be used only to implement this particular networking mechanism. So how we are going to access, or how can we identify, or based on what instruction this particular networking is going to made, that is going to decide it. So that's why we can say that the internet networking environment is going to be the combination of the hardware and software. So in the hardware, what we are going to do is we are giving that the physical device existence with some characteristics, that is with the help of the physical layer, and the amount of information in terms of frame what we are going to transfer, that is going to be taken by the data link layer. And another one, that is network layer. What the network layer is doing is defining the address, the that particular destination and origin addresses by this, and at the same time it is going to providing the routing mechanism. And now along with this, to complete your networking or to complete your communication from one node to the another node, or from one device to the multiple number of devices in the internet networking environment, along with that, what we have to need is, we are also need, there is a maintenance of some software is also needed. So here, this particular software is nothing but it is available as a protocol. Why? Because the protocol is nothing but set of rules. Already we know that. So those particular rules are to be followed, are to be implemented while completing the communication networking environment. So here also, in the place of software, we are going to incorporate some predefined rules or the predefined set of instructions that is called as a protocol structure. So what are the two different protocol structures we are having in this type of software is one is a TCP protocol and one more is the IP protocol. We are having TCP and IP protocol. One is the transmission control protocol, TCP is nothing but, and second one is we know that that is an internet protocol. That is already we know the meaning of IP and IP address. So transmission control protocol in a sense, it's like your internet protocol. What is the transportation layer we are having in the OSI modem? Okay, it is also this particular TCP and IP is also like your OSI model. But we are having some similarities in between the OSI model and the TCP or IP model, and we are having the dissimilarities also. Okay, however, it's not our concept. Okay, here, what is the meaning of the software in the internet working you have to maintain is you have to maintain some protocol. So what the protocol you have to maintain is it may be the transmission control protocol, that is which is going to be helpful to control the information transfer. That is the function of the TCP. And another one is we are going to use the internet protocol. Okay, now in the world era, what we are going to is we are going to use is the internet protocol. So now we are also going to continue continue our topic with the help of this particular internal protocol structure only. So here, this particular internal protocol structure will act as a software in order to complete the information data transfer with the help of all these particular layers. అంటే ఆల్రెడీ ఇన్ ఓఎస్ఐ లేయర్లో మనం స్టడీ చేసేటప్పుడు ఏమేమి సాఫ్ట్వేర్గా యూజ్ చేస్తాము, ఏమేమి హార్డ్వేర్ యూజ్ చేస్తాము అనేది వీ హ్యావ్ స్టడీడ్ దట్. సో అలాగే ఇప్పుడు నెట్వర్క్ లేయర్లో కనుక డేటా ట్రాన్స్మిషన్ జరగాలి అంటే కంపల్సరీ there should be incorporation of some software tool, that is incorporation of some protocol, some set of rules or set of instructions. So those are going to be inbuilt with the help of either TCP protocol or the internet protocol. So but most commonly used is the internet protocol. Of course, the TCP is also available, but we are going to prefer this particular internet protocol. Why? Because the flexibility of understanding the IP addresses by anyone or by any user. That's why we are going to prefer this particular internal protocol structure. So before going to see the IP logical addressing, that is now what we are going to see is in the network layer with the help of this particular internet protocol, how we are going to represent that particular address. So what is that address and how we are going to represent that particular address, that we will see that. So now, what is the name we given for that is IP address, that is internal protocol address. And what is the size we are using for this IP address is 32 bit. Okay. So this 32 bit, how we are going to represent this part 32 bit is, ఇప్పుడు అన్ని డివైసెస్కి ఏదో ఒక ఐపీ అడ్రస్ ఇవ్వాలి. అంటే ఇప్పుడు ఎన్ని నెంబర్ ఆఫ్ ఒక ఐపీ అడ్రస్ 32 బిట్లు ఎంత ఉంది అంటే ఎన్ని నెంబర్ ఆఫ్ డివైసెస్ మనం కమ్యూనికేట్ చేస్తున్నట్టు 2 power 32 డిఫరెంట్ అడ్రసెస్ మనకు వస్తాయి. 32 బిట్ అడ్రస్ ఉండటం వల్ల ఎన్ని నెంబర్ ఆఫ్ డిఫరెంట్ డివైసెస్ వస్తాయి, 2 power 32. అంటే ఆల్మోస్ట్ how many number of devices we are communicating is 4 billion number of computer systems we can communicate without any overlapping of unique address. That's why we are saying that IP address is an unique address and it is an universal. Why? Because no other device is utilizing that. No other device utilizing, in a sense, if any device is utilizing and if you want to reuse, we can go for that option also. And I told that you have to deactivate that particular system if any IP address is utilized by someone, and after deactivating that we can reuse that particular IP address by another system. So like that also we can convert that. But here you have to identify this particular this particular internal protocol address. Okay, here this particular IP, this particular 32-bit address is going to represented in two representations. One is in binary format, it can be represented, and another one is the dotted decimal format, we can represent that. One is in the form of binary we can represent, and second one in the dotted decimal form we can represent it. Okay, already we know the format of the IP address, that is 162.12. Something we are saying that something dot something dot something dot like that. Okay, that is nothing but the dotted decimal representation. But actual representation of the IP address is this is the binary representation. But for the sake of users and for the easy representation of the system, it is converted with the another approach, that is the dotted decimal approach. Okay, now we will see that particular decimal representation of the IP address. So as it is having the 32-bit address, it is going to represented as 4 octets. That means the complete the 32-bit is going to be represented as 4 octets. See, an octet in the sense it is equal to 1 byte. So total 32-bit logical address is going to divided into the 4 bytes. Okay, why it is divided is in the complete 32-bit address. Okay, we are having some identification. It is only completely not the identification of the specified device, and along with that, for networking path, that is a network layer or networking path జరగాలి అంటే net ID is also there. That is what is the media we are using, that is also to be specified in that particular IP address. So that's why the IP address is going to be categorized into the different parts, and within that particular address we are having the different representations. And it's not completely representing the device identification, this device ID. Along with the device ID, it is also giving your networking ID. Networking ID అంటే ఏంటి? ఒక డివైస్తో మనం కమ్యూనికేట్ చేస్తున్నాము అంటే దాని రూటింగ్ వేరు, ఇంకొక డివైస్తో మనం కమ్యూనికేట్ చేస్తున్నాము అంటే దాని రూటింగ్ వేరు. సో ఇప్పుడు ఒక డివైస్ కనుక ఇఫ్ ఇట్ ఈస్ కమ్యూనికేటింగ్ విత్ దిస్, సి if this computer system is going to be communicating with all these devices, so this particular one is having one IP address, this is having one IP address, this is one having another IP address, like that. And if you want to communicating all the devices with at the same time, so what we are going to do is with the help of routing protocols we are going to communicating. అంటే ఇప్పుడు 30 ఒక బిట్ అడ్రస్ 32 బిట్ అయినప్పటికీ ఎన్ని నెంబర్ ఆఫ్ అడ్రసెస్ మనం మెయింటైన్ చేయొచ్చు అంటే 2 power 32. సో 2 power 32లో ఇదొక ఫస్ట్ బిట్ అడ్రస్, ఇంకొక అడ్రస్, ఇంకొక అడ్రస్, ఏ అడ్రస్ రిపీట్ అవ్వదు. అట్లా అని ఎన్ని నెంబర్ ఆఫ్ డివైసెస్ మనం కమ్యూనికేట్ చేయొచ్చు అంటే ఓవర్ 4 billion నెంబర్ ఆఫ్ డివైసెస్ వీ కెన్ కమ్యూనికేట్ విత్ ద హెల్ప్ ఆఫ్ 2 power 32. 2 power 32 అంటే టోటల్ వాట్ ఈస్ ద వాల్యూ ఆఫ్ 2 power 32 ఈజ్ this much value we are having. This much number of computer systems can be communicated. సో ఇన్ని నెంబర్ ఆఫ్ సిస్టమ్స్ ఎలా కమ్యూనికేట్ అవుతాయి అంటే ఈ నెట్వర్కింగ్ పాత్ అనేది ఇట్ ఈస్ గోయింగ్ టు బి ఆర్గనైజ్డ్ విత్ డిఫరెంట్ రూటింగ్ పాత్స్. ఓకే, దట్ ఈస్ అబౌట్ లాజికల్ అడ్రసింగ్ అండ్ రూటింగ్, దట్ ఈస్ ఇంప్లిమెంటెడ్ విత్ నెట్వర్క్ లేయర్. ఓకే, సి that's why the IP address is represented with a specified representation. So that's why it is represented as a 4 bytes. So completely it is not included the host ID, అంటే ఎక్కడికి పంపించాలి, ఎక్కడ నుంచి తీసుకుంటామని ఐడితో పాటు networking ID కూడా we are going to mention that within that particular IP address. So this particular 32 is going to be divided into the 4 octets there. Okay, let us represent for simple example. Let us consider the first octet as 0111 and 0101 and 1001 0101 001101 and all zeros. So of these octets, 4 plus 4 is 8, 8 and 8, 8, 6, 7, 8. Okay, it is 1 octet. So total 32 bit in the sense it is having 4 octets. That is 4 number of bytes it has. So this is the binary representation of this particular IP address. Okay, in the dotted decimal representation, how we are going to represent that is, see, what is the decimal equivalent for this? That means each and every octet is separated with dot. In the dotted decimal representation, each and every octet is going to be separated with dot. At the same time, each and every byte is going to be represented into a decimal one. Okay, so the decimal equivalent of this will be, what is the value for that is, it is having 117.149.29. Okay, it's equal to 29, and here it is. What is the value for this?
2, sir.
Yes. Okay, right. So it is equal to 2. That means decimal dotted decimal representation, in the sense this is the dotted decimal representation. Okay, already now we are having the awareness about this IP address. Okay, daily in our lives we are using an IP addresses. That is what is the format we are using there in our lives is dotted decimal representation. Why? Because actually this is the basic IP address representation, but for the easiest understanding of the user, it is converted into a dotted decimal representation there. ఇప్పుడు ఐపీ అడ్రస్ డివైస్ ఐడెంటిఫికేషన్ ఇవ్వబడింది. దట్ మీన్స్ ఇప్పుడు ఐపీ అడ్రస్ ఐడెంటిఫికేషన్ ఇవ్వబడింది అంటే ఇప్పుడు కమ్యూనికేషన్ నెట్వర్కింగ్ ఎన్విరాన్మెంట్ మనం ఫామ్ చేస్తున్నప్పుడు ఒక స్పెసిఫిక్ అడ్రస్ అనేది అసలు ఎగ్జాక్ట్ ఈ ఐడి అడ్రస్ అనేది కరెక్టా కాదా అనేది కూడా యూ హ్యావ్ టు చెక్ దట్. దట్ మీన్స్ యూ హ్యావ్ టు ఐడెంటిఫై. నెట్వర్క్ లేయర్ ఏం చేస్తుంది? ఆఫ్టర్ ఫైండింగ్ ద లాజికల్ అడ్రసెస్, ఐపీ అడ్రసెస్, then it will make a networking path when only the identified addresses are fine. If they are fine, means that if they are having the error, or if it is the suppose if that id is not available there, అసలు అది ఐడినే రాంగ్ ఐడి అనుకోండి, దెన్ ద నెట్వర్కింగ్ పాత్ విల్ నాట్ బి ప్రొవైడెడ్ దేర్ బై ద నెట్వర్కింగ్ లేయర్. సో నెట్వర్క్ లేయర్ విల్ ఫస్ట్ ఐడెంటిఫై ది ఐపీ అడ్రసెస్. If it is found as correct, if that IP address is found as correct, then it will provide a networking path for the purpose of a communication. So how we are going to identify the IP addresses is, okay, we know the basic function. Suppose if you make all are is equal, if all are equal to 1, so what is the value we are getting? If all 8 ones are 1, if all 8 ones are 1, to calculate it. So what is the value?
255.
Is anyone doing it, or
255, sir.
okay, right? So now how we are going to identify if you are using the IP version 4 is so 255 dot 255 dot 255 dot 255. ఇప్పుడు what is the minimum range and what is the maximum range of the IP address is all zeros, that may be the one device, and the last IP address of the 4 billion connecting computer devices is this will be the IP address. Okay, suppose if you are using another digital combination there, another binary combination, if you are going to getting the another IP address, and at the same time as you are going to getting the maximum number of this as 255, so no that means any number cannot be more than 255. So if any number is found as greater than 255, we are going to say that it is not a valid IP address. So when you are going to say that a valid IP address is, if any one of these octet is greater than 255, we are going to say that we can decide that. And ఇప్పుడు నెట్వర్క్ లేయర్ how it can identify is, it is going to be check the maximum number. If it is within this particular range or not, if it is found as greater than 255, then it is not a valid ID. So again, it is going to be checked over for valid IP address. Okay, like that it is going to be checked. And at the same time, suppose if you are representing that it is an 0.02. Actually, it is the decimal equivalent of this is equal to 2, but it is represented as a point 0.02. It's not a point. We are going to say that it's a dot. 117.149.29.2 dot 02 in a sense, it is not going to represented in your decimal format. So it is also not a valid IP address. Okay. So under that situation also, it can, this particular identified address is found as invalid, and again it is going to be checked over for the valid IP address. Okay, like that we are going to check. Suppose if you are having 17.149.29.2.5, that means we are having totally 36 number of bits are there. But actual IP address representation is only the 32 bit, but here we are representing it as a 36 number of bits are there. That is, we are having 4 more bits are going to represented there. Sorry, total 40 bits we are represented there. And this is also an invalid IP address. So like that, an IP address is a specified format, and each and every IP address is going to divide into the octets for the easy representation of an IP address, and like that we are going to check for a validness whether this particular IP address is a valid address or not. Okay, this is about an IP addressing. Okay, now after identification of this particular IP address, now it is going to be start the routing. When it is going to be start the routing, when we are having the multiple number of IP addresses are found, and if the device, if there is there a need in order to transfer the data from these particular devices to the multiple number of devices, then it is going to make the routing mechanism. Okay, routing mechanism in a sense, if you are having the number of addresses are more, okay, the routing will be provided only when you are accessing this much number of addresses. అంటే ఇప్పుడు ఒక స్పెసిఫైడ్ వ్యాలిడ్ అడ్రస్ని మనం యాక్సెస్ చేస్తున్నప్పుడు రూటింగ్ అవసరం లేదు. ఎప్పుడైతే when you are going to access the multiple number of addresses among these particular 2 power 32 number of addresses, then we are going to provide the routing mechanism. Okay, that is also going to be taken in the form of the software by this particular internet protocol structure. So in order to implement this particular routing structure, what this particular IP, ఇప్పుడు ఐపీ అడ్రస్ అనేది ఏంటి అంటే ఓన్లీ ఐ వ్యాలిడ్ ఐడెంటిఫికేషన్ ఇస్తే డివైసెస్ ఎన్ని ఉన్నాయి అనేది మనకు తెలియదు. So in order to discriminate that in this particular total 32-bit address representation, it is going to divided into two parts. That is, the complete IP address is going to be having, one is net ID, that is networking ID, and second one is it is having the host ID. The IP address, what it is having the composition is, it is having the networking ID, that is a net ID, and second one is the host ID. See, in this kind of computer networking, while you are going to routing, means that through this particular network path you have to route the communication for this device to this device. For this particular route you have to give one identification, that is a network ID. Okay, it is a host ID. So how we are represented the host ID, that is a complete 32-bit representation, and within that particular 32-bit representation, it's not completely representing the ID of your destination device. Okay, remember that this complete 32-bit representation of an IP address is not the address of the destination device. అంటే ఆ డెస్టినేషన్ డివైస్ ఐడెంటిఫికేషన్తో పాటు ఏది ఉండాలి అంటే, why? Because as it is an internet networking environment, every device is going to maintain a different ID, unique ID. There are no common IDs. No two devices are maintaining the common ID. So that's why as they are having the different IDs, every device is going to be communicated over a different network path. So for every network path also we are going to giving some ID, that is called, that we can say that is a logical addressing. అంటే ఐడి స్పెసిఫై చేసిన తర్వాత దానికి కూడా ఒక సపరేట్ రూటింగ్ పాత్ మనం మెన్షన్ చేస్తే that can be treated as a networking path. So in this particular networking path is some identification. That means through this path I am going to communicating, and for the further communicating of another device I am going to providing another path over there, that is also called as a network ID. But this particular amount of the network ID and the host ID is going to be varies depending upon the representation of IP addresses. Okay, we are having a different classification. For host ID, how many number of bits are going to be represented, and for networking ID, how many number of bits we are going to representing. We are going to have the different a classification of those particular IP addresses again. Okay, simple IP address will not define the complete information. Again, the IP is divided into the different parts, that is networking and host ID. But how many number of bits are going to be used for identification of the network and the host ID again? That is also going to be differed depending upon your networking environment. So based on that factor, it is going to divide into the class A, class B, class C, and B, class C, and E. We are having the class A to the class C. Based on that, a number of bits are going to be allocated for a networking ID and host ID. Okay, we are having a different classification discrimination is there. That's a very lengthy topic. In order to segregate that particular total 32 bit into the different parts. Okay, so that we will continue from the next class. Just this is the introduction to the network layer. In the next class, we will continue that. Again, how many bits, each and every bit, what it indicates, and how many number of bits are going to differ for each and every class, we will see in detail later. Okay, right.